Hello everybody, Nikita Eremin here, and we continue our talks on Python essentials. Let's see which options do we have in Python for string manipulation and solving some basic algorithmic problems. A string in Python is a sequence of case-sensitive characters. You can compare strings with equals, greater than, less than, and other comparison operators. You can use the len function to get the length of the argument string. Here's an example. The string ABC is assigned to variable s. Calling function len on s string returns an integer number of 3. You can use square brackets to perform indexing into a string to get the value of a certain position. String indexing always starts from 0. Negative indexes are also possible for strings. It means you address character position starting from the end of a string to its beginning. For example, index of -1 corresponds to a last character, -2 to a character before the last one, etc. Please be careful specifying the index. If the value you provided is greater than string length -1, you will get out of the bounds error. Now let's see how we can slice a string. Slicing a string means getting a substring of it. You can specify up to 3 integer numbers in square brackets, separated by colons to perform slicing. First number is a starting index, second number is an ending index, and the third one is a step value used to iterate through the string characters. By default, step value is equal to 1, meaning you'll be getting each character between the start and stop index specified. Interesting, you can omit or even provide negative numbers for start, stop, and step values. Omitting start value means you indexing from the beginning of the string, and missing stop value corresponds to the string length value. Specifying a negative number changes the direction. For instance, you provide a -1 for step and omit start and stop. The result will be a reversed string. Python strings are immutable, meaning they cannot be modified in memory. Instead, each manipulation produces a new string object. In the example shown here, you'll be getting an error when trying to assign a new value directly to a single string character. To replace the first character with a new value, you should concatenate it with a sliced substring without the first character. This will create a new string object you can assign back to the variable. Now, let's see how strings and loops cooperate together in Python. Consider these two code snippets. Both of them do the same thing. Given a string value, they check each character and print out a message in case a character equals to I or U ones. Both of them use for loop. However, first code snippet is using explicit string indexing to get a value of each next character, which should work, but looks a bit redundant. The second one is a more to say Pythonic way. Note there's an in operator used in for loop specification, instructing it to get a next character on each iteration and place it into a char variable. Here's one more code sample illustrating this approach. Instead of creating a while loop with an index position as a param, changing from 0 to the string length, you should use for loop with in keyword. In this case, your code looks much more neat, while Python interpreter is doing some work behind the scenes for you. Let's consider some calculation examples. Imagine you have some integer number and want to find another integer, which is a cube root of the first one. The simplest approach is checking all numbers starting from 0 up to the first number. We can calculate the power of 3 and check if it's equal to our first given integer. This approach may sound a bit naive and inefficient. However, that gives you a basic idea of how the whole class of algorithms work. We can call it guess and check approach. The other naming for it is exhaustive enumeration. The basic idea is the following. You are able to guess a value for a solution by trying sequentially values from some limited number of variants and checking if the solution is correct on each iteration. But what if our cube is a negative number? Unfortunately, our first version of code won't work in this case. Let's see how can we modify it to support negative cubes. We can use abs function in Python to get an absolute value for a number and compare with absolute of our given cube when checking for a solution. Finally, when we found a solution and our initial cube value is negative, we should make the result negative too. There's one more use case. Given any integer, we could fail to find a solution in case it's not a perfect cube. There is no solution in the space of integer numbers. We can check if we ran into this situation by comparing our guess variable value powered by 3 with an absolute value of the given cube after we have completed the loop. There is no integer solution if these numbers are not equal. Let's think about this further. If there is no integer solution, we can run same algorithm checking possible float values. The question here is, what will be the step will be increasing our guess with each next iteration? The answer is, we should use as small value for it as possible. However, if we make it too small, the number of iterations will increase orders of magnitude, making our solution way too slow. Approximate solutions are always a trade-off between accuracy and speed, so as said, you should take smallest possible epsilon, not affecting your program speed much. The other approach to consider, you could take the greatest epsilon value, which give you a good enough solution. Here's the updated version of our code. Now the increment value added to our guess on each step is 2 orders of magnitude less than the epsilon value defining the accuracy. That's because if we make the increment equal or too close to the epsilon value, we may just miss the solution when checking for it.